Hello, welcome to the design of IoT project using Raspberry Pi and code written in Python. In this project, the temperature from two sensors has been read and the data is being fed into cloud, MongoDB, and also in ThinkSpeak. The first step, the Raspberry Pi board has been prepared with a Linux operating system. Then the hardware circuit was implemented with sensor and connection wires, and this data from the sensor has been fed to Raspberry Pi external input output pins. After receiving the sensor's data, it has been passed through low pass filter, so it will have stable data values from the sensor. And LEDs has been used to know the status of data's high range or low range, and pulse width modulation is being used to know that how intense the light is, which is calculated based on the temperature's higher and lower value. And later this data has been passed to ThinkSpeak on the cloud and also the database MongoDB, which is in the cloud. A separate Python script has been written down to collect the data which is stored in MongoDB and to generate a data analysis report. And finally, the data security topic has been discussed. So this is the overall scenario of the project. Temperature sensors TC474 and TMP36 is being used to read temperature. And the data has been saved in databases which stays in cloud and in ThinkSpeak. So for temperature, as we know that TMP36 gives out analog output, so it has been passed through analog to digital converter. A chip called MAX1243 has been used to convert the analog signal to digital signal and pass it to Raspberry Pi. TC74, which uses SPI protocol, so no analog to digital converter is being needed and it was directly passed to Raspberry Pi. This is a circuit diagram. A switch also being used to acknowledge the alarm when it goes out of maximum range. This code has been used to read data from sensor and pass it to cloud. This function updates the PWM signal for the light LED, and this main while loop updates all the data and pass the data to cloud. And this script has been written just to read the data from MongoDB and make a plot with some data analysis of the data in the MongoDB. So if we go to the database, we can see that there are two tables or two collections. And if you go inside TC74, we have some data being read, and also same in TMP36, we have some data being read continuously with every 5-second interval. And if we check our ThinkSpeak report, we can see that the latest data is being updated. A gauge meter has also been used for field 1, which is the reading from TC74, and TMP36 data is also being updated here. The Linux system have some security stuffs that can be relied on, which is the basic one, first login authentication. It also have permission on file level, which helps to protect a specific security file or a specific file that other than admin should not have access. And it also supports remote connection SSH, which is secured, and it has also some encrypted protocol which make it safer to communicate with. And finally, it has some authentication check periodically, which helps to verify if there is any unwanted connection has been connected. The second part of this project is to design another connection to read another project to read sensor data and use MQTT to save data in MongoDB. So in this project, MQTT broker has been used to transfer data. So similarly, like the previous project, sensor data has been read and it has been pushed into MongoDB using a MQTT broker, and separate Python script has been written to subscribe the channel and to update a data analysis report based on every interval when it receives data. So this has been the architecture has been used to design this project. TC74 has been used as a temperature sensor, which is passed into the Raspberry Pi, and it has been published to MQTT broker. Using MQTT broker, it has been published to the MQTT cloud, and the similar data has been also saved in the MongoDB. And with every published data, this separate Python script which is subscribed to this channel is being updated, and in every update it pulls latest data from MongoDB and generates the report. So if we go to this program which is being used to read data from MongoDB and generate data based on the every new data arrived in this MQTT broker. So here we can see that new data has been received and data analysis has been generated. And this piece of code which is running in the Raspberry Pi is reading the temperature sensor. After passing it to the LP filter, it is passing this sensor data with some interval to MQTT. So if we have a look on the MQTT broker, then we can see that with some every fixed interval we receive a new data from the Raspberry Pi device. So final thoughts about MongoDB security is that it also have the authentication check while connecting a new connection. It also have role-based authorization. So for different connection, different authentication user ID. It also implements authorization. So based on the role, different level of security can be managed. And it also supports some custom logging and audit option. So while data is coming in, it can be audited as well. Finally, MongoDB also have some encryption mechanism which helps to secure the data. That's all for this project. Thank you very much for your time.